This is going to be my first in a series of videos in which we're going to explore data sets, but doing so using what we call the 5-number summary for the data set, as well as a box plot to describe it. So as opposed to finding, say, the mean and making a histogram or a bar graph out of it, what we're going to do is we're going to focus on the 5-number summary, which really kind of focuses around the median, and then also how the data is spread using a box plot. So a box and whisker plot is sometimes also how you hear that name instead of a box plot. But what this does is it communicates to your audience where the middle of the data is. And again, the middle, our primary measure of middle here is going to be the median, is what we look at here, as well as how the data is spread using like the range. Okay, so in order to create a box plot, I say here, we have to be able to find what is referred to as the 5-number summary for a set of data. And according to me, the 5-number summary is these are the numbers that split or partition the data set into what we call fourths, or another name for this you'll hear sometimes are called quartiles. What quartile your data point lies in when we split the data into fourths. And so we say that these 5 numbers are as follows. The first number is always going to be the minimum, and the last always the maximum. And I'll just point this out here. The middle number, I call this Q2, and I call this the median. Okay, well, of course the median's in the middle, but why Q2? Because what we're going to be doing is taking a set of data and splitting it into fourths. What we're really going to be doing is saying, say this geometrically represents my data set. We're going to split it in half. We're going to split the halves in half. And what we get is this. We get the minimum. The end of our first 1/4 of data will be here. The end of our second 1/4 of data will be here. And this will be the median, essentially. And we'll say the end of our third fourth of data will be here, and then our maximum here. So when you hear Q, what I'm really referring to is a quartile, and a quartile is a fourth of your data set. So Q1, basically, it stands for the end of the first quartile of data, or the first fourth of data. The end of the second quartile is going to be the median. End of the third quartile is, of course, Q3, and then the maximum, we don't call it Q4, even though it would fit the scheme, but we just call it the maximum, okay? So what we're going to do first before we make a box plot is practice finding this 5-number summary. And so what I have here is this. I want to find the 5-number summary for the following set of data, and these data represent scores that were recorded on a ProbStats, class on a quiz. Okay, they take a quiz and they get these scores here. We'll call these percentages, okay? So I see my student scores. The first thing I want to point out is this. If you're going to be finding the 5-number summary, the data must be in order. Has to be in order. That is, we're really ranking data when we find this 5-number summary. So in terms of what our 5-number summary is and what it consists of, the very first 2 numbers we should always find are the min and the max. And in order to find the median, we'll just count in. Now I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data. So when we count in, I might count in 1, 2, 3, 4 this way, and 1, 2, 3, 4 this way. The idea here is this, though. We landed on 2 numbers. This data set had an even number of data. So when you land on 2 numbers and you're finding the median, we always find the average of these 2 numbers. Now I certainly could pull out my calculator and find the average of 86 and 88, but the idea that I want to point out here is this, is when you find the average of 2 numbers, you're really finding their midpoint. So it is very reasonable that that's 87 there. So I'm going to put a box around this. It's very important that we box it. And I'm going to label this. I'm going to call this Q2. I should call this the min. I'll give it a lowercase m, and the max I'll give a capital M. Okay. So as far as finding Q1 and Q3, we said, well, we'll split the data set in half when we find this 5-number summary. And in order to find Q1 and Q3, you can think about Q1 as being like the median of Q2 and the minimum, and Q3 as being the median of the maximum and Q2. So basically we're going to count in from the middle to the outsides. And so here's one thing I do want to point out. When you count in, you're obviously, if this was, on paper, I'd put my left finger right here and I would put my right finger over here somewhere, but do I start my left finger on 80 and then start my right finger on 87? Or do I start my left finger on 80, obviously, and start my right finger on 86? And we always start inside the median. I don't even care if you landed on 1 number to begin with. This isn't because I landed on 2 numbers and had to average it. We start inside the median, okay, when you count in. So that means that whatever the median is, you're going to move 1 number in, and you're going to start counting in from here. So from 86 and 80 counting inward, we say 86 to 84, 80 to 81. 84 to 82, 81 to 82. So what this means is our Q1 is going to be this 82 value right here. So we say the value of Q1 is 82. And counting in between 91 and 88, we say count in, count in, count in, count in. We land on this 90 right here. So the 5-number summary, really easy to find, are essentially these values right here. And often you'll see somebody asking you to list them out this way. Okay. So not something that I'm exploring in this video, but something that I will mention is this. You sometimes hear percentile rank as well, what percentile you're in. And so we'd say, okay, well, our minimum here is 80. Q2 or Q1 is 82, Q2 is 87, Q3 is 90, and then we say M, our maximum is 91. So we say what percentile you're in. So for instance here, I would say that 87 or Q2 is in the 50th percentile, but because it's bigger than 50% of the data set, whereas Q1 here is like the 25th percentile because it is bigger than 25% of the data. This is our 75th percentile here. This would be our 100th percentile on the end, and then this would be like our 0th percentile. So again, the 5-number summary is basically splitting this up to rank data. Okay. Now that we have this rank, though, in order to create a box plot, basically we say a box plot consists of a box in the middle and whiskers on the outsides. Okay, so we say it's created by placing each of the numbers in the 5-number summary above a number line appropriately. It says we sketch whiskers from the first to the second dot. So in other words, the whisker is going to consist of this distance here from 80 to 82 and 90 to 91. The whiskers on the outside, and then we are going to put a box around the middle 3 here, essentially, where the median is always this middle line, and we have a box going from Q1 out to Q3. So what this really does is it allows us to see the middle 50% of data very well. And then we can pay attention to the outside. So in order to create this box plot here, basically what I'm going to ask us to do is put these numbers on a number line. And because I'm going to be comparing them to these box plots over here, we're just going to foreshadow a little bit. I noticed that, I put these data sets in order already. I'm saying that these are 2 other classes that say took the same quiz, and I'm going to be comparing them. And so since I'm going to compare them, and I noticed that the lowest minimum is a 60 between all 3 data sets, and the highest maximum is at 91, I'm going to go from 60 up to 100. We're going to start down either before the minimum or at the minimum if it's a nice minimum like 60, and we're going to go up past the maximum. So on this particular number line, what I'm going to do is I'm going to say, let's consider this to start at 60, and I'm going to go up by tens. So we say 60, 70, 80, 90, 100. Okay, so now that I have these on there, it's appropriate to say scores, and I'm going to list as a percentage to label what this number line equals and also give this graph a title. Okay, so a title, I'm not going to worry about it so much here, but I might write box plot for the performance of students on a prob stats quiz. So when we make our box plot, we're basically going to put a dot above the number line for each of these 5-number summary values. So for instance here, I'm going to put a dot above 80, and maybe we do this actually. I'm going to put little tick marks here to indicate half marks. We only need to label it going by tens, but we say 82. 82 would live right next door to this. Our next value is 87, so 87 would be about right here, 87. And then we say 90, 90 is right here, and then 91 right here. And what's going to happen is we are going to connect the outside lines to the inner lines right next to them, and then we're going to put vertical lines through each of these inner 3 dots. The box always goes around the inner 3 dots. But what I want to do is I want to kind of articulate a few things here, starting with this. When you look at this graph is excellent because it tells you precisely where the minimum is and precisely where the maximum is. So when we talk about what are some other things that I could describe with this graph right here, I suppose we could describe the range. The range is going to be the distance from the max to the min. Recall that in this case, our maximum was 91, minus our minimum, which is 80. And so we could say this range is 11 units of span, 11 points, 11 percentage points, from the highest score to the lowest score. We can also see other things like this right here is our Q2, but another name we could give this is the median. So when we look at a box and whisker plot, we often look for where's the middle of the data, the median value is here, and then how is this spread apart. I would say that this class did fairly well, given that the median was about 87, we can see here, and they were very consistently packed around the median. That is, it wasn't a very big range. It didn't spread very far apart. And another thing we can look at here is essentially this. We'd say that 50% of your class, if you're the teacher, scored between an 82 and a 90, which the range there, 82 to 90, would say is a span of 8. So we're looking at the middle of this data set. Okay, so what I want to do here is essentially this. What I want to do is find the 5 number summaries for each of these data sets over here, which I already put in order for the sake of time. But let's say 2 other classes took the same quiz and they also have 10 students in each class. Once we find the 5 number summary, what I want to do is I want to create box and whisker plots for these. And what we're going to do is we are going to compare how these 3 classes did by reading these box and whisker plots. And in the next video we'll move on to a discussion of outliers. So the 5 number summary for this, to be very, very concise about it, is essentially we need our minimum and our maximum values. So we say min is 60, maximum is 85. Counting in, we get 1, 2, 3, 4. Counting in here, 1, 2, 3, 4. So it's split between 75 and 75. So this must mean that our Q2, or our median, is 75 here. Counting in, starting at this inner 75, we say 1, 2, 1, 2. So 73 is our Q1. So we have Q1, Q2, and then we need to find, let's see, starting inside this middle 75, 75 to 80 to 80, we say 80 is our Q3, and then we have our max and our min. So down here we have min, max, 1, 2, 3, 4, 1, 2, 3, 4. So this one also has a median of 75. So comparing them to this class above, we would say that they have the same median score. Let's look at their quartile data. So we say counting in from this inner 75, 1, 2, 1, 2, we land on this 74 right here. So we say 74, this is our Q1, or end of the first quartile of data, end of our first fourth of data, and then counting in here we land on 80, okay, 80. So we say Q3. Okay, so putting these on the number line, what we want to do is we want to be as consistent as possible with the number line we made over here on the left. So I'm going to call this 60, 70, we'll go 80, 90, and you want to try to utilize the entire number line, 100, so we'll put these notch marks down here as well. So 60, 70, I'm going to skip putting a title on these and labeling the number line here, but I'm going to put the half marks as well. So making our box plots for these, just very, very straightforward. Like, we will say that our minimum datum here was a 60, is a 60. We say 73, 73 will be about right here. 75, so 75, okay. 80, right here, and then 85. So our whiskers will proceed outside here, and our box, sorry about that, that's a little better. We'll put vertical lines through these, and we'll compose our box. And so some things about this, I can see this has a much higher range than this class down here, which means that we must have had somebody that did very poorly on this. We may argue that this is an outlier or not. I'm going to put a question mark. But also the middle 50% of data kind of scored in the same amount of spread as this one down here. The range, overall range, was just bigger on this one. And then we can see that the maximum score up here was a 91, and the max score here was only an 85. Okay, and then stacking this other 5 number summary down here, we say that its minimum score is a 69. 74 is our next datum, our Q1. Then we had 75, so 75 is right here. And then we say 80, 80, and then 91. Okay, so whiskers and box. We can see things like where the median lies. So this one had the same median as this class up here. It's just that its box here was a little bit further to the right, I would say. I mean, it stopped at 80, but this left side, this Q1, was in a little bit further. And you notice that it has a lot shorter line on the left whisker here. So we would say that 25% of our kids were somewhere between 69 and it looks like 74. Whereas 25% of our kids over here were between 80 and 91, which means we had some higher scores, or at least maybe what we might consider an upper outlier on this one. So when asked to compare the shapes of these, you might say that this one down here was very consistently packed, or in other words, to reference a piece of evidence, its range was much smaller than the range of these 2 data sets up here, considering that the range is this distance all the way out there. Okay, and I should put that probably in a different color. There's our range. Okay, so much broader range is here. At least the middle 50% of kids, we can talk about how they scored. They were a little bit further to the right. The box was further to the right here than the box is here and here. So in the next video, we'll consider what is an outlier and how we determine if something is an outlier. Cheers.